Hi again. I'm anyway. I'm I'm Alireza, and I'm presenting this paper, Optimization Methods for Personalizing Large Language Models Through Retrieval Augmentation. This work is a joint work with Surya, Kallumadi, and Zamani, my supervisor, and I did this when I was an intern in Lowe's. So let's first think, what does it mean to personalize a large language model? When we talk about personalizing a large language model, we mean that, let's say we have some external information about a specific person, and we want the generated output be tailored to that specific person. For example, if you look at this example here, if the input prompt is name 2 good books that I should read, the output can be something like, I don't know, Harry Potter and Order of Phoenix and Animal Farm. But if we have some information, some document that is written by that user, or it is about that user, for example, somewhere it says that I am a history student in a university, or somewhere it says that I'm interested in movies, and for example, Hobbit is my favorite movies, then if we ask the same question, we get better personalized output, which is, for example, Lord of the Rings, and the other one is the History of Middle-earth, which is in the same series. So this is what we mean by a personalizing large language model. 1 year ago, we in our previous paper, LAMP, when large language models meet personalization, we introduced a new data set, and also we introduced the first try to personalizing large language models using retrieval augmentation. In this approach, you can see that we have one input, which is the prompt from the user. We generate a query from that prompt, and we use a retrieval model to retrieve the most similar document from the user profile. And we use the retrieve document to basically create a personalized prompt and then feed it to the large language model to get a personalized output. And you can see that here in this work we used Contriver, BM25, and Recency as the retrieval model that we had. But how we can improve these models, such pipelines? One of the main problems with this pipeline is that the components that we have in this pipeline are pre-trained, but they are not task-specifically designed or trained. And the main reason is that there are many non-differentiable operators here in this basically pipeline. And fine-tuning them is difficult and challenging. But we have some solutions. For example, we can use reinforcement learning or knowledge distillation to train such retrieval models to help personalized generation. Also, we have one other observation, that personalization is, it's personalization. It has multiple different dimensions. It's not like question answering, that something that is related to this question can help in answering. Sometimes a completely non-relevant document that has the writing style is more useful in personalizing the output than something that is relevant. So we found that when we use different retrieval model, sometimes one of them get better results and sometimes the other one. So another solution could be when to use which of these retrieval models when we have a retrieval pool for personalizing large language models. So based on our observations, we have two main contributions, and the first one is a method, we call it Retrieval Optimization for Personalized Generation, or OPG. Here in this approach, we use two techniques, reinforcement learning and knowledge distillation, to train a retrieval model that learns to retrieve personalized data from user profile based on a query. In the reinforcement learning approach, our parameterized policy would be the retrieval model. It assigns a probability to each of the actions. Here, the actions are basically selecting one document. So when it selects one document, then it has, other documents as the action, and it can have a trajectory which is selecting some of these documents. And then as the reward model, what we do is we consider the downstream performance of the frozen large language model on the personalized task as the reward function, and we return this reward to the retrieval model and use reinforce algorithm to do the optimization. We also use a baseline, which is the initial parameters that we started our model with. The other approach is a knowledge distillation, which is a bit different. So again, we use the personalized performance of the large language model on the downstream task as the signal to train this model. But in this method, we fit each of the items from the user profile to the retrieval model independently, and we evaluate each of the outputs, and we get the personalized performance of those. And then the retrieval model also assigns a probability to each of those items in the user profile. And then we use knowledge distillation with any loss function, something like KL divergence, to force the distribution of the scores we get from large language model become similar to the one that we are getting from the retrieval model. Personalization has multiple dimensions. If you look at this figure, this shows that the winning rate of each retrieval model on each of the tasks that we used in our paper. I will go back to the task. We will go to the task later, but you know. So if you look at this here, you can see that even the retrieval models that was trained for the on these tasks, on average, you can see that they get basically the same results. So sometimes BM25 performs better for one query, sometimes the trained model performs for the other query, and sometimes even no personalization performs the best. And this suggests that we should move toward designing a mechanism to select retrieval model. To do this, we introduce retrieval selection for personalized generation, or RSPG. What does this do? It's like it gets one retrieval model and it generates one score for the retrieval model, and then we select the retrieval model with the highest score as the retrieval model that should be used. But we can do this in two different ways. One of them is pre-generation retrieval selection, and the other one is post-generation retrieval selection. In the pre-generation retrieval selection, what we do is we retrieve documents using each of the retrieval models, then feed it to the retrieval selection model, and it selects which of these documents should be used, which of these retrieval models should be used. In the post-generation, we do that, but before feeding it to the retrieval model selection, we first feed them to the large language model, and we get the generated outputs. And we also condition this retrieval selection based on the generated outputs, and then we assign a score to each of the retrieval models. It is obvious that the second approach is much more expensive. So if you have n retrieval models, it is n times more expensive. And yep. So let's talk about the data that we are using. The LAMP benchmark. The LAMP benchmark is a benchmark of a diverse set of personalized tasks. There we have 3 classification tasks and 4 text generation tasks. The good thing about this benchmark is that each sample in this benchmark, each basically example in this benchmark, can be considered as a separate user with its own profile, input prompt, and one expected output for that specific user. And if you look at the statistics of this benchmark, you will see that even for the test and dev sets, we have a lot of users. So when we find something in this benchmark, it has a good generalization, basically. And you can see that for the profile size, we have a lot of profile. For example, for some of the people there, on average, we have around 200 different documents written by them. And the tasks are personalized citation identification, movie tagging, product rating, news headline generation, scholarly title generation, email subject generation, and tweet paraphrasing. These are the results that we got on the LAMP benchmark, but let's divide everything to some research questions and then answer them. The first research question is that how does personalizing using the proposed approach impact the generation performance? What we see here, when we train, our retrieval model using our approach, we see that we outperform all the non-personalized large language model on all the tasks significantly. This is really important because in our previous work, basically, or our current baselines, there was a tweet paraphrasing task that none of the basically retrieval models that we had could outperform non-personalized language model on that one. So this is interesting, and that one is maybe one of the most difficult tasks in this benchmark. The other question is that how is ROPG, retrieval optimization for personalized generation, impact the text generation performance? In order to do this, we consider contriver as the baseline because contriver is the checkpoint that we started training from. And when you look at the result, you will see that we outperform contriver on 5 of these tasks on citation identification, product rating, news headline generation, email subject generation, and tweet paraphrasing. Generally, we found that our knowledge distillation performs better when reward that we get is binary, so it's like accuracy or things like this. But again, in general, there is no always binary between ROPG, RL, and ROPG KD. So it again suggests that retrieval selection is important. The other research question is that basically, what is the best method to personalize large language model, or comparing with the personalized baselines that we had there? We use BM25 recency, country-var, and some rank fusion baselines, some rank fusion methods as the baseline. And if you look at the results, you can see that our proposed approach significantly outperforms on all the tasks except scholarly title generation. We believe that the main reason for this is that, while it is possible to have different writing styles when you are writing a scholarly article or something like this, but we follow some specific kind of format. So we think that even non-personalized large language models are pretty good at that task. The other research question that we have here is how effective is the retrieval selection method that we use? To study this, we considered some query performance predictions baseline like WIG, NQC, sigma max, and sigma 50% as the baseline. The main reason that we didn't select something like BERT QPP is that they need training data, and basically they need QRELs, and LAMP benchmark doesn't have QRELs because it's very difficult to annotate the data set for personalization. And if you look at the results, you will see that our retrieval model selection approach using knowledge distillation from large language models significantly outperforms all the baselines. And as we expected, RSPG post-generation works better than the RSPG pre-generation, but it is more expensive. And in conclusion, for this paper, we studied various methods for optimizing information access component in a RAG pipeline for personalized generation. We introduced a method for optimizing retrieval model using reinforcement learning and knowledge distillation. And also, we introduced a retrieval prompt-dependent, basically, retrieval model selection module to select the best retrieval model for each specific input. Our experiments show that reinforcement learning and knowledge distillation helps in optimizing retrieval model for selecting personalized information from user profile to do large language model personalization. We found that personalization have different dimensions, and we showed that it's not possible to answer all of them using a single retrieval model, and we need basically somehow select different retrieval models. And also we found that selecting retrieval models from a retrieval pool significantly outperforms all other baseline and all other methods in this paper. Thank you so much for this talk. And if you scan this QR code, it will take you to our LAMP benchmark paper. There will be a lot of papers about large language model personalization, and thank you for your attention.